Find f of 0 for each. So the first one, we've done this a lot. You just plug in 0. 2 times 0 squared minus 9. That's going to be 0 minus 9 is negative 9. So f of 0 equals negative 9. All right, we've done that a million times. There's nothing new about that. But the next one, for some reason, throws people for a loop. Some of these other ones throw people for a loop. F of 0, think about it as you're plugging in x equals 0. All right, if you're plugging in x equals 0, that's right here, and you're going to get this number right here, 8. The answer is 8, and that's all there is to it. There's nothing to that at all. If you plugged in 0, you're going to get 8. So another example, what if I said f of 2? What would f of 2 equal? Negative 2.
Oh, okay, so that answered my question. I was just going to say if it was like 0, negative 4, then f of 0.
Yeah, you got to look at the x number. If I said f of negative 4, you'd say 0.
Yeah.
If I said f of 5, that's undefined because that's not even on the page, right? Okay. Now, we're still finding f of 0. What do you think f of 0 is on this mapping?
4.
F of 0 equals 4. Very good. You just follow the arrow. Plug in 0, you get out 4. That's it. Now, the graph is also fairly simple, but students just don't see this one, okay? You have to think about, for f of 0, you have to think about the x number is 0. So look at where x equals 0 on the graph. Well, here's where x is 0. So you look at that point on the graph. Okay, that point is 0, 2 on the graph. That means if I plug in 0, I'm going to get out 2. F of 0 equals 2. Number 8, the figure shows the graph of a function. Determine the intervals of the domain over which the function is increasing, decreasing, or constant. So half of this is hard and half of this is not. You look at the graph and you should immediately be able to tell that it's increasing here and it's decreasing here and it's constant here. All right. That graph is increasing for a while and then it's decreasing for a while and then it's constant for a while. Everybody sees that, but what everybody messes up is they don't see this part that's talking about the domain. We're talking about the domain, so we're talking about the x numbers, right? Okay. So what you would have to do is think about what would happen if you squished that graph onto the x-axis. Talking about domain. So if you squished it onto the x-axis, you'd have a red part there, and then the decreasing part would be like right there, right? And then the constant part would be right there. You have 3 different intervals of the domain. You've got a red part and a green part and a purple part. Okay? The red part is the increasing part. So just look at the x. Look at the x for the increasing part. Okay? If you look right here, that is the interval from negative infinity to, think about your x number. Don't look at the y number. A lot of people look at the y number. I want to look at the x number because we're talking about domain. What is that x number? Say it. -1. -1 right there. That's where it switches to green. So going to -1. Now, you could argue that it either equals -1 or doesn't equal -1 right there. I could see both of those arguments. I think Math Excel is going to make you put a bracket there. Okay, so the green region, the region in the middle, is where this graph is decreasing. If I want to talk about that interval, I want to only look at the x numbers. And those x numbers are going from what to what? -1 to 1. Very good. Again, Math Excel is going to make you put brackets. The purple part is where this thing is constant. So only look at the x numbers. It's going from 1 to positive infinity. A lot of people mess up on that because they want to look at the y values. They're like, it's increasing up until 2, but I don't care about the y. I'm looking at the domain. Number 9. Answer each question about the pool. When does the water level start to decrease? Okay. Well, you can see that it's decreasing right there, right? When does it start? Means look at the x number. What x number where it starts? 50, right? It's decreasing from there to there. Okay. So it starts to decrease, I'm going to say at t equal 50 hours. Over what period of time is the water changing most rapidly? What do you think they're saying when they say changing most rapidly? What's a math word for that? What do you think they're talking about? What? Increasing? Well, it could be increasing or decreasing, but how would you know which one is changing most rapidly? Exponential would be yes, but I don't see an exponential here. So that might not be what they're talking about in this case. Can you tell where it's changing most rapidly?
Ooh, is it
slope? Very good. Slope. What about the slope would tell you if it's changing more rapidly or not? Steeper. That's a great word right there. Steeper. Okay. So can you tell where this is the steepest? Looks like right here to me. Over what period of time, over what interval, that means look at the x. It looks like from 0 to 25 hours. Very good.